So first and foremost, I'd want to express my gratitude to Dr. Jeffrey Halverson, Ms. Jennifer Artis, Mr. Kevin Fulmer, for taking their time off from the busy schedules to join us today and help evaluate the candidates. I'd also especially like to thank Dr. Hrebrowski for stopping by. Before the program commences, I'll quickly go over the agenda and rules for the today. The competition will begin soon, and before the contestants present their work, we have speeches from Dr. Halverson, Joel, who's the president of the Graduate Student Association, and our guest speaker, Dr. Mustafa. I'm sure the judging criteria has already been shared with all of you. The presentations are limited to 3 minutes maximum, and competitors exceeding 3 minutes will be disqualified right away. Once the 3-minute window is up, the judges will have 5 minutes to jot down their feedback. At every level of the competition, each competitor will be assessed on the comprehension, content, engagement, and communication. So if the contestants and judges have any questions, I'd be happy to answer them now. Any questions from the contestants? Yes, please.
Did we get any indication of time you're running?
Yes, so I'll be holding the placards, which we have a time slots of 1 minute and 30 seconds. So when 1 minute is remaining, you'll have the 1 minute placard up, and when 30 seconds are up, remaining, you'll have the 30-second placard up. Any more questions? Okay, thank you. I am Sai Sriram, and I'm serving as the co-chair of the GAIRS committee. It is my pleasure to invite you all to the 3-minute thesis competition. Each year, the GAIRS committee seeks to prepare graduate students for their careers by challenging them to present their work passionately and effectively. To achieve this, the committee serves as a platform for students to share their research work with their peers, faculty, and the entire UMBC community. We also appreciate the graduate school support and promotion of the GAIRS committee. 6 students have come forward this year to present their work in this competition. We appreciate them taking the time and effort to formally present their work. We applaud your dedication to your profession and your desire to share your findings with your peers. The GAIRS committee gratefully acknowledges those who helped make this event possible. We would like to thank the GSA Executive Council, the GSA Senate, the standing committees of the GSA, and the Office of Graduate Student Life for their valuable support and input. We also like to thank Dean Rutledge, Dr. Halverson, the Associate Dean, for their indispensable guidance and support. I'd like to specially thank Mr. Scott Morgan, the President of the Morgan Group of Washington, D.C., our professional communication counselor, for his contribution and his continuous assistance in helping students improve their presentation skills. Additionally, we would be remiss not to mention the multitude of contributions to this event made by Don Galindo, whose dedication to the GAIRS committee is fundamental to its success each year. Before we get started with today's competition, I would like to introduce the committee members of GAIRS. Masood Ahmed, who is the co-chair, also happens to be a participant today. Amna Amjad, a PhD student in the chemistry and biochemistry department, is currently serving as our office manager. Our communications manager is Shakira Bandaru, a graduate student from the Information Systems Department. And now, it is with pleasure that I invite Dr. Jeffrey Halverson, Associate Dean, to address the gathering.
Folks, this is not a speech from me by any means. I just want to extend my welcome from the grad school on behalf of Dean Janet Rutledge. Dean Rutledge is actually traveling across the continent of Africa this week. She's doing some good academic work down there, and hopefully she's taking in some of the amazing sights there as well. Isn't this wonderful? We are all back in person. I think this is lovely, and the GSA, what a beautiful job you folks have done. This is just gives this the honor and respect and prestige that it deserves. This whole 3-minute thesis thing got started the University of Queensland in Australia, and it caught on like wildfire, and the whole idea is swept around the world, and it's a big deal here in the United States. And these contestants you're going to see, there's 6 of them. They have worked extremely hard, and what they're doing is really developing their professional skill set. They're taking it to a different level that's going to be really important, because the research work that you do is of intrinsic value, but when you can stop and explain it to a lay person and not take an hour of that person's time. We call this the elevator speech, right? We always imagine if President Hrabowski gets on an elevator on the ground floor and you get on with him and he says, tell me about what you're doing, and you know you only got a short trip to the 10th floor. Can you do that, right? So we could call this the 1 minute Freeman Hrabowski, competition as well, right? These contestants worked with a professional, Scott Morgan. He comes and works with us every year to help hone and polish their skills. They've put in a tremendous amount of time and effort. And the other thing I will say is that 3MT really brings out the incredible breadth and diversity of research that we have at UMBC. I'm always astounded to see the complexity and the depth and the creative ideas that are just going on everywhere. And this is just a little showcase, a little piece of so much more that you don't see going on behind the scenes. So there is just so much intrinsic value in having this. The last thing I will say is that we have a celebrity among us here. He's going to come up and speak to you in a few minutes. His name is Mustafa Al-Adhami, and he won the National 3MT several years ago. So I'm going to get off this podium. We need to get on with this show. Thank you, everyone. I'm just delighted to see you all. Turn it back over to the MC.
Thank you so much, Dr. Halverson. We are really fortunate to have your guidance and feedback. Now that we have Dr. Hrabowski here, I want to ask if you would like to speak to the audience here.
Sure. And I'm going to see if I can do this in 1 minute. College presidents and politicians get so much time. The most important thing I can say today is congratulations. For all of you, you're in grad school. You're doing great things. You're learning how to express yourselves to people in general. If you get a chance, look at my TED Talk. I had someone professionally work with me on that, and it says 4 major pillars: high expectations, building community. It takes researchers to produce researchers, and then evaluate what you're doing. And so I want you to think about how you can say it just that clearly, with confidence. And every now and then, smile. Thank you all very much.
35 seconds. That was really good.
I'm proud of all of you. Bye-bye.
Thank you, Dr. Hrabowski, for gracing the event with your presence. Now I'd like to welcome Joel Tyson, the president of the Graduate Student Association, to the podium to speak to the audience.
Good afternoon, everybody. Of course, Hrabowski took my 1 minute speech joke, so we'll just move on. On behalf of the Graduate Student Association, it's my distinct pleasure to welcome you to this very special event. In my last graduate commencement speech, I ruminated about what it is that makes UMBC graduate students so special. And one of the things I came up with was that UMBC graduate students go above and beyond to make a deep impact on the greater world. So everyone involved in this 3-minute thesis event is a prime example of that special UMBC graduate student. Despite the brevity of the talks that you're going to see today, the speakers and organizers of this event have all spent countless hours to develop and perfect the set of concise presentations. All of this has been in service of communicating complex, world-changing ideas that will impact the greater world. None of the students here, organizers or participants, are going to get extra credit on their transcripts or graduate any earlier for these efforts. So in that way, this event represents a true labor of love. So I'd like to close my welcome by giving a big applause to all the Gears organizers and the 3MT participants here today, and welcome to this year's in-person 3MT Gritty Talks.
Thank you so much, Joel. We appreciate your relentless commitment to the advancement of graduate students. Moving right along, it is now my pleasure to invite the guest speaker for today. Dr. Mustafa Al-Adami, a UMBC alumnus, received his PhD from the Mechanical Engineering Department in 2020. Mustafa is well versed in this competition and can proudly call it his home turf. He had won the first place and the People's Choice Award back in 2018. He later won the second prize at the regional level in 2019. And believe me when I say the best is yet to come. Like Dr. Havison rightly mentioned, Mustafa had represented UMBC at Nashville and was declared the national winner. We are overjoyed to have him here today. Please join me in extending a warm welcome to Dr. Mustafa Al-Adami.
It's really easy to win 3FT. You just need to drink a glass of wine before you go on stage. I'm joking. I just have to really, this is the most fun I had as a graduate student here, really. Like, don't be nervous, just enjoy it, because work is in the lab, right? So when I wanted to get away from work, I just did 3FT, and it's just the best thing. Like, this is what I remember when I think about my time at UMBC. And even as a kid, right? Like, we always thought of these two opposites, work and fun. And we always thought, well, if an adult is making you do something, we call that work. And then if you wanted to do what you wanted, that's fun. And 3MT was one of these things that was fun. It doesn't mean that work cannot be fun, and it doesn't mean that fun cannot be hard. Sometimes you could fall off a tree when you're a kid playing there. So what I'm trying to say is really, there's one way to have fun when you're working, and that is working for a startup. And that's what I'm here to talk to you guys about. So, working for a startup, of course, I love it, I enjoy it, but really the best thing about it is you'll be doing something that you're not qualified to do. So you could be a fresh grad running the engineering department at Aspen Diagnostics, for example, or I graduated fresh out of UMBC and I was called CEO and I have to make decisions next day. You start by faking it, and within a couple of years, you're up to speed and you're doing great things, right? But you're not doing it alone. You're doing it with a few well-selected people that you call friends, and that brings this family culture into a startup. You don't need to go through HR to talk, to ask for a favor, to ask for a day off. No, you just go talk to me in Aztec's case. If you go work for a big company, you're working on one specific thing, right? So you're very good at X. But if you are working for a small company, you're working on everything. So by the end, you are becoming this well-rounded person. You not only know the technical aspects that you're working on most of your time, but in our case, we're building a medical device, right? I had a fresh grad writing a DA submission, and I would not imagine anyone doing it before the age of 50, probably, in a bigger company. The most important thing is the rate of work, right? Because you have to figure it out yourself, right? So you learn so much when you work for a startup. Now, having said that, there are cons, and the first con is management is bad. I managed this stuff. We're so bad at it. I just finished my degree. I could barely self-manage. Now you're asked to manage 6 other people. So don't expect to manage if you're working for a startup. The other thing, mentorship does not come easy. You need to pursue being mentored. And that's the second thing that people would think it's a con when you're working for a startup. People always say working for a startup is a lot of work. And that is true, and can be considered as a con. However, you're working for something that is yours. When you work for a startup, chances are you own a piece of the startup. So your hard work will eventually pay off, maybe by becoming rich, but it's very unlikely, right? very small percentage of startups actually make it. Become this success, you become a millionaire at the age of 26. However, it's okay because you're building something that you care about, you're working for a mission that you actually care to fix. And if it doesn't work, hey, it's fine, it didn't work, move on to the next one. It's just like in dating, right? You don't go into a relationship thinking, hey, what if we break up? I mean, happy ending, of course, you get married, have kids, and get a dog. However, if it fails, you learn so much, you date another person until you find the right person for you. To stick with this analogy, working for a big company is like moving back in with your parents, right? It's safe, it is stable, but chances are they will put you in the basement. And they might still kick you out at the end of the day. So the real reason I'm here is to recruit. If you're graduating student, smart, I don't care what your major is, hit me up and let's talk about a potential job at Aztec Diagnostics. Thank you guys for listening. I just have to mention one thing. I am sweating way less than the first time I presented here. And I guess this is the biggest thing you'll learn when you do 3MT. Thank you. Oh, sorry.
Yeah, sorry. Before you're leaving, I just want to thank you for coming. And if anyone has any question to Mustafa, you feel free to ask. I mean, we are very lucky to have him among us. So, any question to Mustafa related to the 3MD competitions, related to any other journeys? Basically, I have. Okay, I'll give him a chance first. Okay.
So when you were pitching to investors and such, did you use your 3MT speech or anything from your 3MT speeches when you did your elevator pitch?
I did not use it with investors because if you are at my 3MT pitch, I really just talked about Game of Thrones. So I was a little bit more serious. The one thing that I used was that, hey, first I can do it, it's really easy, and they will not know that what I just said is not what I practiced in front of them, right? So that these are the skills that actually keep going with I would say it's a good question. It's fun, just have fun.
I have a quick question. What motivated you to be a job giver rather than being a job seeker?
Well, so there's a huge problem, right? I care about that problem, and it's more than it being a job provider. It's actually I want to solve that problem, and it takes resources. It takes people that are as passionate as myself about solving it to do it, right? I wish I could do it myself, but it's impossible, right? And when you're in school, I feel like it's always one of two things. So first they say you finish, you either go to graduate school or go work for a big company, or in case if you're in graduate school, you go to academia or work for a company. And this third option, starting your own startup is actually a great idea. At least that's from my experience with it.
Any other question? No. Basically, I like to ask you a question.
Yeah.
So, before giving startup, so first you need to find a problem, right? And then, for any new entrepreneur, if they want to give a startup, they first need to find a problem. So, what do you suggest? What's a good way to find a new problem and approach for that problem? What do you think about that?
Has anything ever happened to you that made you feel uncomfortable? Anything. And it could be from standing in line at the grocery store, right? That's one problem that people go. Anything. Traffic. It's raining. Maybe you could fix some invisible umbrella, right? It's just whatever whatever can make your life easier. Whenever you find something that you don't like, think hard, and be innovative, and you find a solution for it. Anything. Yeah.
Thank you. So, any other questions? Thank you. Stefan. Yeah.
I wish I could stick around for KFC, but we have to go back to work. Very good to see you.
Thank you very much, Dr. Mustafa. I'm sure your speech has instilled confidence in the contestants and has motivated them to present their work today. Without further ado, I would like to invite Manpreet Singh, our first candidate for the afternoon, to take the platform and showcase his work. Manpreet belongs to the Mechanical Engineering Department and will speak about how thermal damage of cancerous tumors can be optimized. Good luck, Manpreet. Here's an important announcement though. While a candidate is presenting their work, we request everyone to remain seated. Judges will have 5 minutes to score the work after the presentation is done. People can scroll up to the food tables during this time and replenish their plates.
No, unless there's clarification.
Every single day, we are losing some important lives throughout the world. I'm talking about cancer. There is a great proverb given by the scientist, philanthropist. Any disease that cannot be cured by medicine can be cured by knife or surgery. Any disease that cannot be cured by surgery can be cured by iron. Any disease that cannot be cured by iron can be cured by nanoparticles. Isn't it interesting? Yes. We have shown through our research targeting these nanobullets to the tumor interstitium would help to enhance the heat to all the tumor boundaries, and especially targeting it for glioblastoma type cancers. So what's the answer we're trying to seek? We're trying to optimize the treatment. We're trying to reach and kill all the cells that are intact with the healthy layers. How can we do that? We can do that when the nanoparticles comes in contact with the alternating magnetic field. These particles release heat with the Néel relaxation mechanism as well as the Brownian relaxation mechanism. In Néel relaxation mechanism, considering me as a particle, the particle swings when it comes in the presence of alternating magnetic field and releases heat when the magnetic field is released. While in the another mechanism, the particle itself moves from one location to the another location, as you can see in one of the bottom slides, how the nanoparticles are diffusing when they come in contacting heat. So how does that happen? This heat is actually increasing the interstitial space, and that renders to increase of porosity, and then due to this enhancement in interstitial space, the nanoparticles can invade the longer diameters of the tumor. And by doing so, we can treat the tumor well within the optimized time. So, and as the interstitial porosity is increasing with the alternating magnetic field, and it is called the safer boundaries, as said the Pankhurist criterion, through which it is body friendly. Alternating magnetic field is body friendly, and once it is targeted, the temperature rise will affect the rise in the thermal damage index that we have achieved in this research. Thank you so much.
Our next contestant is Shreyasi Sengupta from the Chemistry and Biochemistry Department. She'll be presenting her work on surface modification by hydrophobic indium selenide nanosheets by a compound that is quite complex for me to pronounce. So before I ruin the name, I'll quickly hand over the mic to Shreyasi to tell us more about her work. The stage is yours, Shreyasi. Have a good one.
Hello everyone, my name is Shreyasi Sengupta. I am a fourth-year PhD candidate in the Department of Chemistry in the laboratory of Dr. Zev Rosenzweig. And today I'm going to talk about my project, which is surface modification on hydrophobic indium selenite nanosheets by epigallocatechin gallet and its impact on Schwannella unedensis MR1. And this project is supported by the NSF Center for Sustainable Nanotechnology. So, do I start? Okay. So, my research project is to understand the environmental aspect of two-dimensional nanosheets and what will be their toxicity effect in the natural environment. My material of interest is indium selenite 2D nanosheets, which are two-dimensional nanostructures having some properties and applications very different and unique from their bulk precursors and 3D counterparts. The research question that I would like to ask is, what impact will surface modification on hydrophobic indium selenite nanosheets have on their interaction with the biological system? The reaction scheme shows that the as-synthesized, unmodified indium selenite nanosheets are hydrophobic in nature. However, for the biological studies that I mainly intend to do as the goal of my research project, these materials require to be soluble in the aqueous media. I have done surface modification via physisorption to make these materials soluble in water by coating with EGCG and thereby understanding the interaction of the material with this. The full form of EGCG is epigallocatechin gallet. It is an amphiphilic ester and it is also a natural organic matter or a non-simulant. I am trying to understand what can possibly occur when these nanosheets are disposed of in the natural aqueous environment post-use and how will they interact with the biological system. From the growth-based viability assay of EGCG-coated water-soluble indium selenite nanosheets on Schwannella unedensis MR1, an environmentally relevant bacterium, it can be seen that this material is toxic to the bacteria at a pretty low concentration of 1.98, I cannot see it, or 3.90 milligram per liter. And you can see that the viability is very much low. So far, there has not been any studies to assess the environmental impact of this material, and we expect, due to their unique applications, this material's usage is going to increase exponentially in the next decade. So this study shows at what concentration this material can be toxic to the natural aqueous environment, and accordingly, by controlled release, we can make these materials much more safer and sustainable for extensive environmental use. In the near future, I plan to study and understand the mechanism for the toxicity which is seen in this material. Thank you very much for your attention.
Our third contestant for today is Hirak Ray, who belongs to the Human-Centered Computing program. Let me now invite him to the podium to speak about his topic, Towards Understanding Usable Privacy Concerns Among Older Adults. Good luck, Hirak.
Hello everyone, my name is Hirak Ray, and today I'm going to talk about privacy concerns among older adults during the COVID-19 pandemic. Now, most younger adults don't face many problems with learning how to use new technology. However, a study by the AARP last year showed that 34% of older adults have privacy concerns. Thinking back, my grandparents were also hesitant to use online banking applications and preferred walking to the bank instead. But what if older adults were forced to use online tools like Zoom or WebEx because of a global pandemic? I conducted 28 semi-structured interviews to find out which factors affected older adults' privacy concerns when adopting new technologies. I asked them questions about certain privacy features in these tools, like the waiting room or background filters. Now, some older adults did use these tools, but most of them were either unable to find them or weren't even aware that they existed. I was also curious to know which factors motivated older adults to choose the tool that they were using. But most of them said that they just used whichever tool their close friends or family were using at the time. So far we have seen an awareness of privacy features and some conformity in adoption. But most importantly, what we also found was a lack of trust. In specific contexts, like virtual medical appointments, we asked older adults whether they were comfortable with sharing their personal information. And most of them said that if they didn't know the doctor personally, then they couldn't trust them with their information. So we can see a recurring theme of trusting people over technology for this age group. Now, what are our steps moving forward? With these findings, we suggest empowerment through education and advocacy through close friends and family members. In-person training sessions with older adults would help them ask questions and verify whether they were using the tool correctly. Evidence of this was also seen from our participants, where one talked about advocacy through family and another talked about asking questions in interactive training sessions. Questions like, how do I grab the screen? This would help increase their self-efficacy with the tool, their trust with the tool, and eventually reduce privacy concerns. Now, earlier I mentioned that 34% of older adults face privacy concerns, but with my research, I aim to reduce that percentage by offering these insights to researchers and designers of these tools. Thank you.
The next contestant for the afternoon is Masood Ahmed, who is the co-chair of the GS committee. He belongs to the Information Systems Department. I invite him to the podium, talk about his research, how machines can be trained with less or absolutely no data. So, all the best, Masood.
Thank you. Oh, the slides are not visible from here. It's very tough to see from here. So, hi, my name is Masood Ahmed. I mean, most of you guys have met me, or I maybe sent you email as a co-chair of the Gears, but now I've changed my tag to presenter, and I'm studying a PhD at Information Systems, and this is my third year. And the name of my supervisor is Dr. Nirmal Roy. And before that, I actually did my undergrad on applied physics. Okay, so yeah, should I begin? Okay, just a minute. Okay, so everyone knows about the autonomous self-driving car. The backbone of that self-driving car is the video analysis. On the block number 1, you can see a video, and beneath this, you can see something that a machine can understand. This thing is called level, and the whole process from video to creating the level is called the semantic segmentation process. So how we do the semantic segmentation process? So for that, basically, we need to collect the video, then do the level thing that you see manually someone do the things manually. And then we train the model so that if we deploy the car on any new situation, it can automatically generate those levels. So now let's see, in the third block, you can see there are 2 images. So suppose I collected a video from the New York. The top of the top image on the third block, you can consider the image that is collected from the New York. And I leveled those videos of the New York videos. Then I applied the semantic segmentation process. You can see the result is too good because I collected the data from New York, I leveled the data from New York and applied it on the New York. But let's see, I want my robot to be smart, not a dumb one. So I applied it to the UMBC campus. But as you see, I didn't collect any data, or I didn't level any data at the UMBC video. It won't provide good results. You can see the photo on the second block. So
why it's not providing why it's not generating good results? The answer is that whenever we are applying the semantic segmentation, it is just blindly following the examples or the video or the levels you're providing while training the machine. So while training the machine, we just provided only the Newark video and the Newark level. That's why it is unable to provide good results at UMBC. So to make it smart, what we need to do? We need to explain the machine. Okay, don't just follow blindly, understand what's the problem. Train like this way. That's why, instead of just applying to the semantic segmentation on the 4th number block, you can see that I have add one more block that is called feedback block. So the feedback block will refrain the machine to blindly follow. Instead of memorizing the answer, it will just explain him the problem so that if any new environments comes, it can apply the problems accordingly. So basically, if I do that, that is making my robot more robust, more efficient, and overall, it's making my robot more smart like me, I guess. Thank you.
Penultimate contestant for today's competition is Chanda Lawrence. She's from the Chemistry and Biochemistry department, and she's here to talk about controlled assembly of gold nanobipyramids and cadmium selenide, cadmium sulfide quantum dot. Chanda, the stage is yours. All the best.
Hello, my name is Chanda Lawrence, and I'm in the Department of Chemistry and Biochemistry. My advisor is Dr. Marie-Christine Daniel Onuda, and today I'll be talking to you about the controlled assembly of gold nanobipyramids and cadmium selenide, cadmium sulfide core shell quantum dots. So we're all familiar with electronic devices such as cell phones, laptops, projectors, but there's actually an alternative to these devices called photonic nano assemblies, and that's actually what I work on. So if you look in the first block, you can see that the nanobipyramids have optical properties along the width and the length of the nanobipyramids, and the cadmium selenide, cadmium sulfide core shell quantum dots, the red dot that you see to the right, exhibits optical properties as well. The idea behind our research is that we want to couple the lengthwise optical properties of the nanobipyramid with the optical properties of the quantum dot. So if you look in step 1, the first step is to synthesize the quantum dots that are 12 nanometers in diameter and to functionalize those with a molecule that can be used for coupling. In step 2, the really long scheme, first we synthesize the pentagonally twin-face gold nanobipyramid seeds, and then we asymmetrically grow those to dimensions of 64 by 24 nanometers to form a bipyramidal shape. Next, we add a polymer to the ends of the bipyramid to help protect the ends from the next reaction, which is to add a glass shell to the nanobipyramids. The glass shell actually helps guide the quantum dots towards the ends of the bipyramids and not the sides. Next, after the shell is added to the bipyramid, we exchange the polymer on the ends of the bipyramid with another molecule that could be used for coupling with a quantum dot. In step 3, you see that we're introducing the quantum dot to the nanobipyramid, and we form a chemical bond between the two particles to create a dimer. That dimer has optical properties that exhibit a turn-on, turn-off mechanism similar to what you would observe in an electronic device, but that turn-on, turn-off mechanism is controlled by light, which makes it a lot faster than an electronic device. In the final step, step 4, we're adding an additional nanobipyramid to the quantum dot and nanobipyramid to create a trimer, and that actually has maximized optical properties that we can use for photonic devices. So right now I'm on the glass shell part of step 2, adding the glass shell to the nanobipyramid, and then the next step is to exchange the polymer for the other molecule so that we can couple it with a quantum dot. These nanoassemblies can be used in devices such as quantum computers, lasers, solar cells, and other devices such as those. Thank you.
All right. Our last contestant for today is Daeyuan Tan from the Computer Science and Electrical Engineering Department. He's here to talk about his work on traffic light management. The stage is all yours, Dayuan. All the best.
Hello everyone, this is Dayuan Tan from Computer Science Department, and my advisor is Dr. Mohammed Yunis. My topic today is EAT, Estimated Arrival Time. And shall we start? Yeah, okay. So I'd like to share my research on EAT, which stands for Estimated Arrival Time, with everyone. So this problem talks about you give me when you want to start, where you want to start, and where is your destination. I give you the estimated arrival time. And at this point, you may feel like, is this what Google Maps does? Well, my answer is yes and no. For yes, like this example on the left, from UMBC to UMCP main campus, Google Maps tells you how long it takes, and it gives you the shortest route. But as we all know, in many cases, shortest route isn't the fastest route. And what's worse, Google tells everyone go to that route. And also, Google uses mobile phones. So 4 people in one vehicle using Google Maps will be considered as 4 vehicles. Sorry. But our research based on Internet of Vehicles, which is a part of Internet of Things. So in IOV, all vehicles have the ability to communicate with other vehicles and traffic lights and base station and satellites. Those communications give us real-time traffic information. They may include the vehicle speed, direction, location, and include the whole road net structure, include the real traffic volume, how many vehicles on each street, and the traffic lights. Is it green light, red light? We put all those information into our machine learning model and give you more accurate EAT. And this is just the beginning. On top of EAT, we can provide you the traffic volume prediction. So how many vehicles are coming to this intersection and when will they come? Based on that, we can adjust the traffic lights adaptively. So more vehicles in this direction, longer green light duration. And also, we can do the route suggestion and traffic volume division. So some vehicles, please go to this route. Some vehicles, please go to a second route. Some vehicles, please go to a third route. So to avoid the traffic jam. And also, it can provide better service for emergency vehicles. We ensure they have the high priority to pass fast. And all of that give us better traffic service and experience. Thank you very much.
Dayuan, thank you very much. It was a wonderful presentation to conclude the competition. The judging panel will now take a short break of 15 minutes to deliberate on the scores. May I have your attention, please? So before we move ahead with the prizes, I'd like to invite Masood to come to the podium and give away a token of appreciation to a volunteer, Tanjil, who has helped us clicking good photographs for today's event. So Masood, I invite you to come.
Basically, I'd like to say thank you to Tanzil. Yeah, and we will send this photograph to everyone. If you just need, just let us know. We'll just send this photograph to you. Thank you.
So the order will be the People's Choice Award first, the runner-up, and the first prize winner. So I'd like to invite Sahara, who's a senator in the Graduate Student Association, to announce the People's Choice winner.
Hello everyone. And the award goes to, drum roll, Masood Ahmed.
Gold again. Okay, thank you. Thank you.
I'd now like to invite Ethan, the Vice President of GSA, to come forward and give away the second prize.
And the second place winner of the 3MT competition, Shanda Lawrence.
And here we are. I'd now like to invite Joel Tyson, the President of GSA, to come forward and announce the winner of the 3-minute thesis competition for this year.
So the winner of this year's 3-minute thesis competition is Daeyuan Tan.
We'd like to thank all the participants, the judges, and our committee for all the efforts that they've put in. We'd also like to thank Dawn and Ethan for their special effort. A final note of thanks to our judges for being here and help us evaluate all the candidates. Thank you for joining us today. Have a great day.